Hello and welcome to CS230, Web Information Processing. This is week 10 and lecture 19. Today's lecture is called REST Web Services Overview. And thanks to the few of you that are coming to the live classes, I do appreciate it. We are in the final phase of the module of the course. The fourth section, which is 3 weeks, and this section is focusing on understanding and using REST APIs and also building them. So we'll see a little bit more of that today and over the coming days, and certainly in the later lectures that come at 1700 this evening, you'll see some examples, and I'll give you some examples. Later on in week 11, week after next, because we have a break next week, it will be looking at consuming RESTful APIs, and I would, instead of a lecture on YouTube on the topic, I'll leave all of that to the 1700 lectures, and I will be the pre-recorded lectures, and I will be giving a class in Teams on the upcoming examination, CS230. So I won't be using YouTube in week 11, that's 2 weeks time. I'll be giving a lecture in Teams on the examination, and then the final one will be designing and developing RESTful APIs. But we'll be close to that anyway before. Okay, so let's move on quickly. So today's lecture is mostly theoretical. I'll give some examples, of course, and I have a few demos to show you, and we'll work through it. But we're going to focus on REST. You sometimes hear this referred to as RESTful as well, but we're going to call it REST. And that's an acronym for Representational State Transfer. And so REST is one approach to making web services. And web services tend to be some application that sits behind an accessible, HTTP accessible API, which is very well formal and very well specified. And it runs over HTTP or HTTPS, and you can access it from, say, a program. You can access it from another web service, or you can access it from something like Postman. Your mobile phone apps sometimes communicate with services using held on some server, and because the functionality is not built into the app itself, it's just a client, and it knows which services to access and how to access them. And usually that's done by a combination of the HTTP verbs, get, post, put, delete, and patch is another one as well. And these will actually work in conjunction with a protocol. Okay, so we'll see about that later. Okay, so we're going to work through a REST best practice today, how you create a RESTful service using a Node.js app. And in order to make RESTful Node.js apps, we use Express.js. And that's just another Node package. Up until now, you've been using the HTTP package. I've been looking at the, at a very low level approach to building and accessing an example. And we've had this example that's been running continuously through the module where we have this one here, where we have this Ajax Api. So we're using Ajax to make the request to some API, and your API is implemented with the HTTP module sitting on the back end in Node, or with PHP. Some of you are using PHP. I'm fine with either. But we haven't really established any formal way to do this. There's lots and lots of different ways to do it. And now we want to move to a situation where we can formally describe and organize the commands to make the connections via Ajax required, and also how we set up the server to deal with those. So what's happening is we're talking about setting up routes. And we talked about this API/user route that we looked at before. But there weren't easy ways to handle all of it. There's a lot of work to do. So a lot of the work was focusing on how do we implement all this for the different backend technologies, like using MongoDB or using MySQL. And in principle, the program pretty much stayed the same, okay, and the front end stayed the same, but the backends are due to make some changes depending on the technologies we use. And sometimes the handling of those routes needed to be modified. So we want to try to ease that now, so we can focus on routes and having more functionality, and working on our front ends, and consuming the API, using the API. And we do that with the help of Express. And when we talked a little bit about mean type architecture, MySQL or MongoDB, Express, now we're getting to that. So it's Express.js really. A for Angular and N for Node. So, or sometimes people are using React instead of Angular, and it will be. Let's go back. So I'm going to look at how to use a RESTful API using, well, I'm going to use curl. I might use curl, but I'm actually going to use Postman today instead. Okay, so let's have a look at the overview first. So REST stands for representation straight transfer. It's a web standards-based architecture that uses the HTTP protocol. In essence, everything is centered on resources and their access using a common, well-defined interface using HTTP methods. And we know about these methods already. And you can have a look at this resource here if you wish. Okay, so it's a good resource to look at this one here. So REST was first introduced by Wright Fielding in 2000. So it's around pretty much a long time now. Okay, Amy's PhD thesis entitled Architectural Styles in the Design of Network-Based Software Architecture. And you can click on the link to see the thesis if you wish. But with a REST architecture, a REST server or service provides access to resources, and a REST client accesses and modifies the resource. So each resource is identified by URLs if you like, global IDs. And REST uses various representations to represent a resource, like you could have a text-based resource, JSON resource, XML, or all of the above. JSON is very popular, and we like to use it because it's the one we've been focusing on in this module. You could just as easily XML as well if you wanted. And you know, sometimes I used to teach this module, and I used to show an alternative to REST, which was SOAP. I use a lot of XML. So we're familiar with all the following 4 protocols commonly used in REST-based architecture. You had in your assignment 4 and assignment 5, and REST recommends that the resource methods that are used to work with these resources. So a large number of people incorrectly relate resource methods of HTTP put, post, get, and delete. Okay, we can use HTTP methods to implement a uniform REST interface if we want. Okay? You know, but they're 2 separate things. Okay? So get is used in REST to provide read-only access to a resource. Post is used to create a new resource, and delete is used to remove a resource, and put is used to update an existing resource. So you've seen this in your assignment 4. Okay, so these are your resource was some record in a database, and in assignment 5, the resource is some record in a MongoDB collection. So implementing this REST interface doesn't really change much architecturally the way we've been using Node.js in the past or PHP. We're now just formalizing how we structure access into resources, our databases. So HTTP and REST are not one and the same. So with REST architectural style, data and functionality are considered resources, and they're accessed by using a set of simple, well-defined operations. And the clients and servers exchange representations of resources using the standardized interface and protocol, and that's typically HTTP, but it doesn't have to be HTTP. If you use HTTP, we tend to use those verbs. The intention of REST is to make the web or the internet more streamlined and standardized, and Fielding advocates that using REST principles more strictly. This is why people start comparing REST with web HTTP. Fielding did not mention in his thesis any implementation directive, never mentioned protocol preference, and never mentioned HTTP. It's the way we like to do it now. So you're not using REST if you're using HTTP. You actually have to fulfill 6 guiding principles of REST so you can call your API RESTful. So here are the 6 principles. Client server. Separate the user interface concerns from the data storage concerns, can improve the portability of the user interface across multiple platforms, and improve the scalability by simplifying the server components. So you could have a resource with a backend that provides service to those resources, and you could access it using your jQuery on your phone here, or you could start using a mobile phone-based app, say with Flutter or Dart or React Native. It doesn't matter. You know, it needs to be stateless. Every request from a client to a server must contain all of the information necessary to understand the request. It can't take advantage of any stored context on the server. It's stateless, okay? Session state is kept entirely on the client, nothing to do with the server. The server just responds, or the service just responds. It should be cacheable, and cache constraints require that the data within a response request be implicitly or explicitly labeled as cacheable or non-cacheable. So if a response is cacheable, then a client cache is given the right to reuse that response data for later equivalent requests. Makes sense. Speeds things up. It might be slow to read the resource or do some calculation and send it back to the user, but you can save time. You can save time. You should have a uniform interface. So by applying the software engineering principles of generality to the component interface, the overall system architecture is simplified and the visibility of the interactions is improved. So in order to obtain a uniform interface, multiple architectural constraints are needed to guide the behavior and components of REST. Okay, so REST then is defined by 4 interface constraints: identification of the resources, manipulation of the resources through representations, self-descriptive messages, and hypermedia as the engine of application status. Look and read about, again, if you have a look at the API tutorial online, it'll give you some background information. It should be a layered system. The layered system style allows an architecture to be composed of hierarchical layers by constraining component behavior such that each component cannot see beyond the immediate layer to which they're interacting. Should be code on demand is optional. Okay, and that allows REST functionality to be extended by downloading and executing code in the form of applets or scripts, and applets are Java. And that simplifies clients by reducing the number of features required to be pre-implemented. So you could have some functionality that acts on the data, the resource, if you wish. Okay, and you could say, I need to be able to get these resources, but in order to be able to do something locally with those resources, I need to be able to download the code that processes those resources, because I might not have that implemented. So it means that resources and structures and things can change, and you'll be able to download and work with those. Really complex stuff. But we know, for example, that JavaScript, now I'm not recommending you do this, but we know that JavaScript can download JavaScript and execute that JavaScript. And Java can download classes and then execute those classes. You'll probably have to look at security issues around all that, but no reflection module in Java. Well, so it's something important to remember. 6 principles. We also have to think about REST and architectural decoupling. So with REST, resources are decoupled from the representation so that the content can be accessed in a variety of formats. You can get HTML, XML, text, PDF, JPEG, JSON, etc., whatever. Metadata, which is data about data, they're all about the resource, and they're available and used, for example, to control caching, detect transmission errors, negotiate appropriate representation formats, and perform authentication or access control. And most importantly, every interaction with the resource is stateless. So being stateless is one of the 6 constraints that we mentioned already, and we'll examine each of these in detail in the following slides. I'm going to give you some guidelines and tutorial links. It's just a succinct and give you everything you need theoretically for this module. 6 constraints, as we said, are uniform interface, client server, stateless, cacheable, layered system, and we have code on demand, which is optional. So you must decide API's interfaces. You must decide the API's interfaces for resources inside the system which are exposed to the API consumers, and follow this religiously. A resource in the system should always have one logical URI, and that should be a way to fetch related data or additional data. It's always better to associate a resource with a web page. Now, I usually talk about some of these things at the end, but I think it might be a good idea just to bring some of the stuff that I would do at the end forward, so you can have a quick look at it. So I'm going to look at I'm going to look here for a second and show you some APIs that are available online. Okay, so here's an API documentation that tells me about daily cat facts. And so, this is running on this base endpoint, it's called. So this is the URL we contact in order for this to work. Okay? And we can actually see that we have a route here called facts, and that retrieves and query facts. So it's well defined, and we have something about users. Now we won't be able to deal with the users one because we don't have access to data. So we can actually access this. Have a look at this API. It's a very simple API. It just gives you this app that's running and this fact. And it talks about today's facts. And I'm going to use Postman, and you've seen me use Postman before. So we'll have a look at creating a new cat fact here. So we'll just copy this And that will be our URL. So that's our base URL. Now we need to create the root, which is /facts here. As you can see, it's /facts. It tells us this, what we use. And so I'll type in here /facts. And I'm going to send this request. It's a GET request, okay? And I could decide the different kinds of options I want to send, HTTP options, but we're just using GET, okay? So it's fine. I click the send button, and I should get some data back, which is my cat facts, okay, for today. So this is the JSON. So I'm accessing this resource. Okay? So cats can make 100 different sounds. Dogs don't make only about 10. So that's one resource. And you can see there's lots of other information here as well. It was created by this user. It has this ID. Here's the text. Here's the source, and all and the information that we may or may not want it. It's all here as well. So we have this back as a JSON, and we could use this in our program. Here's another one where we can just get some random user information. So you might need to generate some random users. Here's a random user that's been generated here. So we can just reload this and get a random user. So sometimes students, for your assignment, for assignment 5, you might have to make up data to put into your database. Well, you could actually use this one, a random user generator, or you could use the code that I've given you before. So this is not working very well. Here it's a bit slow. Okay, so here's a phone number and a person, and we have lots of information around those. But that was, again, produced by using this random user .me API, and you can see here it is. So I could actually do that, and I could actually pull back a user if I wanted, and this is the JSON associated with a user, this for this resource. And we can have a look and see information about that as well. So I'm going to try this one now. So it was random user API, and again, this is a very simple API. So I'm going to create a new here. Again, I'll make another request here, send. And I can pull back the information about the API, but actually it's not doing this. It's actually giving me the web page like this. Preview the web page. So it just had some kind of error. Okay, so there's some connection error at the moment. And we could see that there was some issue earlier. So we might leave that one and have a look at some different ones. So here's one that gives me kitten. This one. This gives me a kitten image, a random kitten image, 200 by 300, 200 by 200. If I change it here to be 300 by, 300, 300, I get a different kitten. Oh, and I could say 300 by 200. So what's happening here is I'm sending it. So I'm sending a different route here. Okay, so this is just an API that provides images. It doesn't have to be JSON. It can be actual any format that we understand. This is the resource provided using this API to this endpoint. All right, so let's get back to some. So you can see that the structure of the API is decided by the person who wrote it. So any single resource shouldn't be too large to contain each and everything in its representation. So whenever it's relevant, a resource should contain links pointing to the relative URIs to fetch the related information, as we saw here. This tells us everything we need to do here. So this approach is called HATOS, Hypermedia as the engine of application state. And it's a component of REST application architecture that distinguishes it from other network application architecture. With HATOS, a client interacts with the network applications. Application servers provide information dynamically through hypermedia, and that's what we're seeing back here. So the resource representations across the system should follow specific guidelines as naming conventions, link formats, or data formats, and all resources should be accessible through a common approach such as HTTP GET, and similarly modified using consistent approach. And that's what we've seen here. In each of these cases, we were looking at getting this resource, getting this resource, getting this resource, all of this stuff was pulled back using GET to a well-defined route that was part of the. So the client server essentially means then that the client and the application server must be able to evolve separately without any dependency in each other. So a client should know only the resource URIs, and that's all. This is normal practice of web development. Nothing fancy is required for your site. Just keep it simple. So I often have students working on joint projects, 2 projects, and one will work in the front end, one will work on the back end service. And the first thing we do is we decide what the API will look like. And then once we understand what the API will look like, the person on the back end will quickly generate an API using Node and Express, for example, or use the C#, and then they will produce some dummy information to fill the API. Then the person working on the front end can utilize this API, and they can use that for testing purposes. Whereas the person working in the back end can then start implementing all the various features, and nothing needs to change, and both projects can progress and proceed independently. So feeling was inspired by HTTP. So this is reflected in the whole stateless constraint. So you should make all client-server interactions stateless. The server will not store anything about the latest HTTP request and the client made, and will treat every request as new, no session, no history. So if the client application needs to be stateful for the end user, where the user logs in once and performs other authorized operations after that, then each request from the client should contain all the information necessary to service the request, including the authentication and authorization details necessary. In reality, we don't need to do this a lot because we're providing access to resources behind the paywall and all. So you can see, for example, here is an interesting one because we have made our connection to the user. We got this user here, randomly generated user, and we also were able to get this random user API portraits and telling me which portrait we're going to use. So I can pull this one in and get this, and I can see this portrait. So all this kind of information would have been transferred and held by the client as necessary. That would be fine. Do this. So we talk about being cacheable, layered, and code on demand. So caching of data and responses is of the utmost importance whenever they're applicable and possible. Okay? So the web page you're reading, there's also a cache version of the web page. Caching brings performance improvements. We see a little bit of that later in the module. Okay. For the client side, and better scope for scalability for a server because of the load has reduced. So in REST, caching should be applied to resources when applicable, and then these resources must declare themselves cacheable. Caching can be implemented on the server or client side. So for resources of fixed IDs, referring to how they're accessed, then you can see how caching is made easier. Sometimes the root is called the endpoint. So here is the root, and these are the endpoints. API/portraits. REST allows you to use this layered system architecture to deploy the API in server A and then store data on server B and authenticate requests in server C, all this kind of stuff. A client doesn't ordinarily tell who it's connected to the server or to some intermediary along the way. It doesn't matter. You don't have to know. You just have to know the root words. The code on demand constraint is optional, and most of the time you'll be sending static representations in the form of XML or JSON. Where necessary, you are free to return executable code to support part of the application. Clients can call your API to get a UI widget rendering code. It's permissible. I like the feature. It's a bit scary sometimes. So if you want to design then a RESTful API, there's a wonderful article on Hacker Moon about this. Okay, and I'd recommend you have a look and read it. Okay, so what's important here is that everything that we talk about now refers to REST APIs. So resource then is an object or representation of something which has some associated data. There can be also sort of sets of methods to operate on it. So for example, you might have employees and you might have a delete, an add, and an update, or the operations to be performed on the resources. Collections are sets of resources. Companies is a collection of company resource, and URL is a path to which a resource can be located and some actions performed on it. Okay, so the article really gives some nice API endpoints for companies which has some employees. So for example, /get all employees is an API endpoint, or just an API, okay, which will respond to the list with the list of employees. So you might have an endpoint that will be add new employee. If you want to think about the HTTP verb associated with this, you could think about, we don't have to do it here, but you could have something that tells us about it. So API endpoints here. So if we want to get all employees, we have a get, okay? So we would end up using a get request. Add new employees, we would end up using a post because we have to add data. Update an employee, we would probably use put. Delete employees, we could use delete. Delete all employees, we could use delete again. Promote employees, we could probably just use get. And promote all employees, promote employee and promote all employees, we could just get as well. These are independent of the verbs. We're not telling you how to implement them. We're just telling you what the roots are. Okay? And if you're updating an employee, you might have to provide an ID here. If you add a new employee, you might not. You just have to provide the information, and the returned JSON might tell you the details and the record ID. You have that detail. So you have to think about the nouns and the verbs. It's like language. So there can be all sorts of other API endpoints like these for different operations. All will contain many redundant actions. All API endpoints would be burdensome to maintain as the API endpoint count increases. So the URL should only contain resources, nouns, not the actions or verbs. So the API endpoint add new employee contains the add new along with the resource name employee. So the endpoint employees alone would be preferable because we can use that with our HTTP verb. It only references a resource, the noun. So it's good practice to always refer to nouns in the plural for API endpoints, for example, /companies rather than /company, /employees rather /employee. How do we deal with the verbs? This is where we have the HTTP get, post, delete, and put. And that's why I was telling you at this point here, it's not clear which ones we would use, but we say, oh, we could probably use this, we could probably use this, we could probably use this. No, it doesn't matter. What really matters is we know we're dealing with employees in all of these cases, and it's the verb that makes the difference, the noun. Okay, so I used the Hacker Noon resource for this, for explaining. It's really good, and I'd recommend you have a read. Give me 1 second while I get some water, please. Thank you. So the resource should always be plural in the API endpoint as well. If you want to access one instance of the resource, we can always pass an ID to the URL. So for example, if we have the HTTP get method used, a verb, and the path companies gives me a list of all companies. If I say get and the path /company /34, it gets the detail of company number 34, or ID equal 34. A method delete and the path company /34 would delete the company 34. The method get and the path /company /3 employees 45 will get the details of employee with ID 45 that belongs to the company with ID 3. The method post and the path companies will create a new company and return the details of the company created. See, the verbs or the actions are represented here by the HTTP verbs on the resources, which are the nouns. This is how we should design our API. So also some really good representations from Microsoft RESTful API design, and I'd certainly recommend you click through this link here in the bottom page here. It's very similar to the HackerMoon one references earlier. So here's an adventure, here's an API endpoint, adventureworks.com/order/1. It's pretty much identical. I have this information in. You give your resources identifiers, which are URIs that uniquely identify the resource alongside. Clients interact with the service by exchanging representations of resources, and many web APIs use JSON as the exchange format. For example, a GET request to URI listed above returns the response body alongside JSON. Okay, so best practice then. So the REST APIs are given by hypermedia links that are contained in the representation. This example shows a JSON representation of an order, and it contains links to get or update the other customer information associated with that order. And you'll see that we have the reference here. We can get the action get put on this, pull the information. Somebody made this order on product ID, quantity 4, the order value was this, and here's a link to the actual products made by this customer using a get. So the REST APIs are driven by hypermedia links that are contained within the representation. This shows a representation of an order, contains links to get an update to customer associated with the order. And if we go back to our Postman and we have a look at some of the stuff that was returned here, we can see all sorts of information here that contained the one that we have. But getting the random user better. Back here. Allowing me to go back. Again. Okay, I've pulled something. It's still giving me an error here. So, but anyway, here was the random user, and we can see the information that was contained in this. So the actual resources, the information is contained in the API body response, which tells us how to act. Just as I say, in terms of best practice. So really, we'd recommend, or certainly I'd recommend, that you adopt a consistent naming convention in your URIs. And as indicated already, it helps to use plural nouns for URIs that reference collections. Good practice to organize URIs for collections and items into a hierarchy. So for example, customers is the path to the customer collection. Customer/5 is like path to a customer with ID equal to 5. And this helps to keep the web API intuitive. Many web API frameworks can use and can route requests on parameterized URI paths. So you could define a route to the path like this. You might see this when you look at it. So it's also, you should consider the relationships between the different types of resources and how you might expose these in applications. Customer/5/orders might represent all the orders for customer 5. You could go the other direction, of course, and represent the association from an order back to a customer with URIs such as /orders99/customer. Extending the model too far can become cumbersome to implement, so you have to decide where to stop. So better solutions provide navigatable links associated with the resources in the body, as that Microsoft article recommends. Okay? And that explains the rationale for giving an example there earlier. And again, this is the rationale. In complex systems, it can be tempting to provide URIs that enable a client to navigate through several levels of relationship. Customers ID/orders/99/products. That level of complexity can be difficult to maintain, and it is inflexible if the relationship between the resources change in the future. Keep it simple, please. Keep it simple. Really, really important. You should also consider the relationships between the different types of resources and how you might expose these. Customers/5/orders might represent all orders for customer 5. You could go into the other. So we want to go back and look at our verbs. Okay. So get retrieves a representation of a resource at the specified URI. The body of the response message contains the details of the requesters. Post creates a new resource at the specified URI, and the body of the request message provides details of the new resource. The post can also be used to trigger operations that don't actually create resources as well. Put creates or replaces a resource on the specified URI. The body of the request specifies the resource. Look at this. Creates or replaces. So essentially, it could do the same job as post. Patch performs a partial update to a resource. Okay. The request body specifies a set of changes, and delete removes a resource at that URI. So post request creates a resource. The server assigns a URI for the new resource, returns that to the client. In the REST model, you frequently apply post request to collections. The new resource is added to the collection, and a post request can be used to submit data from processing to the existing resource without any new resources being created, of course. The put request creates a resource or updates on the existing resource, and the client specifies the URI for the resource. The request body contains the complete representation of the resource, and if a resource of this already exists, it's replaced. Otherwise, a new resource is created, and if the server supports doing so. Okay? So put requests are most frequently applied to resources that are individual items, specific customer or other. And a server might support updates, but not creation via put. So when a support of creation via put depends on whether the client can meaningfully assign the URI to a resource before it exists. If not, then use post, create resources, and put to update. So it depends on you. A lot of it depends on you and what you have and what's available to you. A patch request performs a partial update to the existing resource. The client specifies the URI for the resource, and the request body specifies the set of changes that apply to the resource. These are just listing stuff as a reference, but it's important you realize. And it can be more efficient than using put, because the client only needs to send changes, not the entire representation. Technically, patch can create new resources by specifying a full set or updates to a null resource if the server supports that, but you may or may not. Put requests must be idempotent. Okay, so if our client submits the same put request multiple times, the result should always be the same. The same resource will be modified with the same values. Post and patch guarantees are not guaranteed to be idempotent. Talk about this. Okay, so here's our endpoint table. So for example, customers 1 customers' orders. And you need to generally do a table like this when you're designing an API. So if we have customers and we have post, creates a new customer, get retrieves all customer, put bulk update of customers, and delete removes all customers. Wow. Carry this one, okay? Customer/1 with post will generate an error. A get will retrieve the details for customer 1. It'll update the details of customer 1 if it exists, and then it removes customer 1 with a delete. Customer 1/orders, create a new order, retrieve all orders, bulk update of the orders, and remove all orders. So, we need these tables, and it's always a good idea to have these when you're working on it. We had a look at some of the REST API examples already, and we'll have a look now at some code. So we want to have a look at the example. Let's not look at kittens now. Here's a really nice open food facts API. You can get food facts, about anything, any food item. You look at a food, get a fact about that. Get its calorie content, sugar, fat, filling apps. It's user. That's there's a nice list of free APIs, but this is the one we're interested in. I'm interested in talking to you about this particular one. So what I'm doing now is I'm going to take the example that we know already and look at two versions of this code. Okay, so I currently have a version of this. We used to be originally called index.js. Now it's index express MongoDB, and you've seen an example. I've provided you with an example where we looked at using MongoDB with this index and PHP, and we also have one where I showed you how to use index and MySQL using HTTP, all within Node.js. So now this example has been morphed into two separate examples. One that uses Express to handle the routes requests that are made in this index.html file, and this one then deals with the resources being in a MySQL database, and this one, the resources sitting in a MongoDB collection. Let's have a quick look at the code. Let's open these three. This index file hasn't changed. Still the same index because I'm retaining the roots. Now, what's interesting about this one here is that the roots are the roots that I use /API/user. Now, this is really bad design based on the lecture I've just given today, but I decided I wouldn't take too many changes. I preserved this so that you can still see how it connects with the other thing. So here's the index.html. You'll see the roots. Let me go down to some of the Ajax calls. And you'll see the Ajax call here. So this is a get request to get the information, and this was a post request in order to get information from. So this is the endpoint, okay, /API/user. Really, that should be API/users, okay. So that if I use a post on it, it would be better. That would be better design. But I'm not changing that design because I want to show you that we're preserving the front end, like the client part, and just working on the back end. So we look at Mongo. Look at this is the program now that handles Express, and it's much shorter, because we're using an Express here, and we're also using a body part. So these two libraries are being used here. And this Express app allows us to be able to handle. This is the MongoDB one. I'm connecting. Now I'm actually doing a slightly different connection to the database here. It's a bit more efficient and shorter than the one I would have used previously. So I have environment variables set up under my Unix backend here for username and password, so I can just pull those out of the process environment, and I'll be able to access those when I'm running. It means I can show you the full code, and I don't have to expose my username and passwords. And in fact, they're not in the file anywhere; they're just set up as environment variables. So that handles that. But you could use the connections that we would have used at an earlier time. So now I'm just creating a Mongo client, which is we've seen this first, and then within that we have we've created an app which is an Express app, and you'll see a little bit more about doing that later. So here's an Express app, okay, and this will handle all of the route handling, okay. Okay, and I'm telling it this app will use this body parser to be able to handle these and handle JSON body and to handle URL encoding. I'm going to run at port 80, and we start off with the Mongo client, and then we embed our app in here. So I'm looking at getting a root. If I get the root / then I just show index.html, and there's lots of comments in here. So if you look at the code and work through the code, you'll see this. So now I have a use/API/user function. And that allows me to be able to find all the information from the users in the database. If I actually get a post request on this root, I'll get the data and insert it into the collection. And that's it, okay? It's nice and simple and short using Express. If I look at the MySQL version, once again, it's pretty much the exact same app. Okay, I'm creating an Express app again here. Body parser is new, I guess, and running in port 80. Again, this time I'm looking at the I'm dealing with MySQL, so I need this library, and I'm actually pulling in the environment variables for my host, my user, password, and database, and so I'm connecting here. Again, they're not in a file, they're not a configuration file, they're not in this program, they're just hit as environment variables. Then I connect in and log, and again, the same kind of thing here. I'm connecting to the root. What happens if I have my root here? So this time I'm, again, sending my index.html, and if this is the time here, I look at the a get request on this root, and I just pull all the data from the database. A post request on this root, I just send something to the database. And you'll notice though that for this particular program, the connections and everything in terms of the connections sit inside the request. So my connection to the database is here, okay? And when I'm using MongoDB, because of the kind of structure of this module of Mongo client here, I have to do this first. And then when I connect, I embed all my Express modules and functions inside once I make the connection to the client. Whereas with this one, I can actually have a connection to the client independently for the database. Slightly different structure here. Okay, so they'll work. Okay, so now what we want to do, and I guess the point I'm making here is that I'm now using Express, and this is the way we're going to do it from now on. Here, and Express with MySQL, Express with MongoDB. And so we have the same root as we had used previously, but we have a get and a post on that root. And it's a bad design because I'm not calling it users. From a design, it'll still work, but not really following good practice. Let's run the programs. So we want to run this one first. This will give me some errors, but I'm deliberately having some errors so you can see why there's errors. So node. Okay, so it's telling me that I can't find Express because I haven't installed it. So I can install that by using npm. Okay, so I'm installing Express. And it's as easy as that. So I run this now. I'm going to get another error, okay? But I run it now. Oh, sorry, didn't run it. Now I run it. It tells me another error because I haven't installed MongoDB. So install MongoDB. These are mine. You'll be able to download these and do the same thing, okay? npm install MongoDB. And so, yeah, that's good. We've installed MongoDB. So now let's run it again. And there we are. It's running. Go to our here, load it. And I should be able to retrieve information from. Okay, so here we are. So it works fine. We're now using Express to handle the routes. I didn't change the front end at all. I've never changed the front end. It all remains the same. Okay, so let's now kill this. And now let's start working on the version that connects to the relational database. Again, I'm not changing the front end. I'm not changing the API structure, but I'm changing how the API works. Again, let's have a look. So this is the one we want to deal with here in the Express MySQL. So we'll probably get some errors when we start this one as well. So we'll have a look. Yep, because I haven't installed module MySQL. I did have these installed. I just uninstalled them to show you that this is what happens when you get an error. Okay, so let's npm Did it again. Doing this. Okay, so this is running now, and now we're running and we're connecting to the API set up. It's running. It's a REST API. It's handling get and post requests on an endpoint / API / user. Should be / users, but it works here for us. So let's go to this, reload it, and get the user data. Fine, you'll see it's bigger because there's more data in there. Okay, and that's really it. So it's here. You know, we could change this, I suppose, if we wanted. We could go to informal. We could say we could change these to users, okay, and users, and it would be in line with this is like the first two parts. And so that's that example. Yeah, and I mean, I should be. Let me run it again. Actually, I'll run this one once more. Okay, so it's running fine here. Now I'm going to look at Postman, and I'm going to send a request here to localhost 8000 / API user and send it. We're using get here, sending it, and we're just pulling back all the information. We could have a post, and we need some keys then, right? So let's see if we can get some keys. F name. We have a post. We have these keys, sending, and we want to see what happens. Might give us an error. Oh, didn't. So it's James blog data added to the database. We got the James blogs from. Anyway, let's have a look and see. Let's have a look and do a get on the data. Send. Pulling data from some there's my Jim blogs. My Jim Jones. I have a feeling I had done this. I had done this earlier, so it added all that information to it. Let's have a look at the post. I have a feeling that's what went on there. It was pulling this information here, but actually I was sending these data here, but I actually had the information in the body here. I had the information set up as a JSON. Okay, so I was playing with it earlier, but this is why we had this James blogs here. Okay, I sent a Jim blog. I sent to Jim as part of the get request by having these data here as part of the formal parameters. So we're sending these parameters, but because we were using post, they're formally ignored by the server. It only cares about the body that was set up in JSON. That's here, which is. So I could change this, make a Jim, say that Jim here, and let's go back to the parameters, because we're actually not going to send any parameters. We're just going to send information in the body request. We don't have a Jim blogs in here anywhere. We have a Jim Jones here, and we send this now. Now Jim blogs is added to the database, and we can go back and make a get request on this one, and we should be able to see Jim blogs is here. I misbehaved slightly. I did a slight. I played with this earlier as a demo. Okay. Anyway, good lesson learned. All right. The post request will ignore the parameters that are sent as part of the URI. Okay, very good. But they're not ignored by the get request. Okay, so that's good. So that's our program running, and this is what's this is all working here on this endpoint set up by this website. Thanks very much for coming on today. I hope you, I'll put these, I hope you have a sense of some overview of REST. There's quite a lot in it, but I'll be showing some more examples in the lessons later this afternoon at the 5 o'clock lecture. And I will be providing these two applications. You can get them working for yourself. So you'll have two good working parts for the next set of assignments. Okay, you can decide whether you want to use PHP, Node.js, MongoDB, or a relational database. Don't mind as long as you actually. Thank you very much for watching. Have a good day.